I guess first off, I'm incredibly glad to be able to present to the happy hour. Um, Kudos to all of you who founded it. When I first started joining, one of the first in early April, it was just quite a change up from the early COVID days, and to all of a sudden be able to reconnect with people that you only see at these conferences that we don't get to attend anymore. Um, it's been quite a pleasure to just attend, even if I don't actually have to present. So background, Sloan, we've been working together. I mean, we originally were working on almost like townhouse code in Seattle like a decade ago. I'll let Sloan at least pipe up and say an introduction, even though I know he wants to geek out on the more technical stuff later.
Yeah, we started, learned about Passive House 10 years ago. And as you can see from this slide, had kind of an evolution since then. Had to do the first one on our own account because there were no customers asking for this kind of thing. And I'll let Brandon dive a little bit more into the details on the particular project for today.
Absolutely. And with Sloan, it was great because, like we said, we started with his first house. It was a challenge to pack it into a tiny lot. It's called Park Passive. It ended up making like the New York Times. It ended up winning the AIA National Housing Award. It was quite a launch project, I think, for both of us heading into it. From there, we moved into View House 5, where we actually were working with another architecture firm as the Passive House consultant. Pax Futura is what we'll talk about today. That was started about 3 to 4 years ago. It's Seattle, so it takes you a while to get through an entitlement, not as long to build. And then obviously now it's built and complete and finished certification in March. And then we also did 320 Queen Anne, which Sloan is currently building for a client I'd worked with for years who hopefully has bought in and going to kind of continue down that road. Nope. So the location, if you don't know Seattle, it is in Southeast in Columbia City. It was a neighborhood that had seen neglect for years, but had the benefit of having light rail put through decade and a half ago, and it now connects the airport to downtown and the university. And so the introduction of light rail has really led to more kind of redevelopment in what was kind of smaller neighborhood center. The site itself is located in between light rail and the commercial core of Columbia City. And that led to some really good decisions from the very beginning. In Seattle, they removed the parking requirement. So from the beginning, the project was focused on bicycles and mass transit without a parking space on the site. The environment around, it's something we've really, started to fuss with as we've got deeper and deeper into Passive House. There's an existing large building to the south, something that is unique because we're now doing work all over the country, but Seattle is much more like Canada compared to what most of us on the East Coast work on, meaning that it can get really a lot of sun in summer from the Northeast and Northwest and gains on the north side that you wouldn't when you're further south. The winter, you struggle with the fact that there is so little light. And I lived in Seattle better part of 2 decades. I only go there for the summer now because the winter, December, there's just very, very little natural light opportunities and the sun gets incredibly low on the horizon. This is also a corner lot, so we were going to have the benefit of 3 right-of-ways with an alley on the north side, but it's also in a commercial zone. So we knew that there was a kind of the inevitable filling in of the parking lot that you can see just behind the house that was there in the diagram. Precedent, back to development. I joke this is the one where I made all my mistakes concurrent to doing Park Passive with Sloan. Around 2008, I bought a parking lot when the Sonics left Seattle and built a 7-story building. I call it Proto Passive. I hired the best green consultant I could, tried to figure out everything we could about systems, built an ideal wall assembly, put in triple glazing, followed everything, and then, as you can tell by the sign, blew it on mechanical as we have our whole house fans blowing all that precious conditioned air out our facade every few hours. But on that project, we really played with interior courtyards. It was a similar orientation, 2 streets and an alley. You're fighting to get light and air. And we did a whole series of buildings where we used an exterior circulation that has the benefit of creating through units. I think another thing that really kind of informed us was by the time we took on Pax Futura, we had done enough other passive house projects that we were beginning to kind of put together a systematic approach. And I've had the honor of presenting this a couple times with Monty and Lois Arena. I've also done it at other conferences, but we eventually developed a large commercial and multifamily class, like a series of different philosophies of how to approach a building. And this was right around the time we did Pax Futura, so we were able to take a lot of the ideas of like unit or floor by floor neighborhood or varying windows by facade in order to control gain. Early on in the design concept too, we ended up with a courtyard in the center, but very quickly kind of came up with this idea of series of grids and grids that respond to the facade that they're facing. So not to suffer from symmetriosis or whatever you want to call architects' love of absolute symmetry, we let each facade behave in a manner that was appropriate for its orientation. So that led us to kind of horizontal windows along the south with fixed glazing. The west was going to be our danger. So we moved to kind of a very playful, movable facade, knowing that there were times of the year we were going to want as much energy as we could get and other times where we don't want anything. And then the east and the north kind of doing what was appropriate for either the interior space or the future condition. The way the project works out, 44 feet across, 108 feet long. There's live-work lofts on the ground floor, a commercial space on the corner. The rest of the floor is actually kind of a laundry room, trash, bicycle storage, and then what actually became a really exquisite courtyard. Up on the second floor, we ended up with a kind of centralized hot water system. So that storage label is wrong, but when you're going through entitlement, you don't know it. A couple other unique things about the project. It is, despite being 5 stories, it's legally 4 stories. It also does not have an elevator. So despite being multifamily, everything above level 2 is exempt from ADA and fair housing. So that enabled us to have some kind of tighter units. But if you look at it, a lot of the things that you would normally see in a multifamily building that eat up space or eat up rentable area, elevators, parking, things like that, were actually not part of the program. And even the circulation doesn't count against FAR because it's exterior. As Monty mentioned, it is a CDU project by the Seattle definition. They're small efficiency dwelling units. There are kind of 1-bedroom units on the corner, but other than that, it's predominantly studios. It also, from the very beginning, had aggressive solar goals, and that did morph as the project moved along. And then the courtyard. Very, very little design opportunity on the outside, meaning we're built to 3 walls, but we wanted to create a really engaging vertical space within the center of the project that could be its core. This is how everybody comes and goes from the project. This is space outside that people experience every day. And in a building like this, yes, there's a little bit of amenity in, I'll call it the laundry room and the amenity room, but it was always meant to be a place where, despite being small, you would be comfortable. There could be multiple people within various parts of the space. Modeling, I think anybody who's heard me speak before, model early, model often. We actually did this project and diving through the records to prepare. We did it in Woofy Passive, we did it in Design PH, we did it in PHPP alone. Maybe not the most efficient way to go about it, but you do get lots and lots of information as you go through. And in looking at details, we really did kind of take this time to really analyze and improve our details. Not to bore you on foundations, but we have half a dozen, 8, 10 different options of just something as simple as how the footing hits the floor slab, hits the exterior wall. And we started with very traditional things like carrying insulation down, trying to insulate around the footing. But in the end, we ended up with something that was actually more efficient and as simple as could be, which is just insulating below the slab, putting a wedge against a curb, having the curb and the footing and the exterior wall come down, float the interior slab. I mean, as simple as could be, simple to build, saves a lot of messing around in the dirt, saves, you know, layers and excavation are on the side, and minimizes insulation. From very early on, it was also planned as a SIP project. So, you know, kind of the patterning and the way of the windows and the repetition was designed kind of around the idea that that was something that was going to be incorporated. Also, you can see kind of the windows and walls. We were really playing with what was the best way to get light and air into the building, but to keep it very simple, minimal modulation, no inside corners, no outside corners, except for what we needed for circulation. And then shading, from the very beginning, we were liked the idea of kind of trying to avoid air conditioning, even though you'll hear that kind of came back in, but also to have people understand where they live, something that they could interact with and something that could help them control their own environment. So we came up with the idea of Precedents of kind of these movable screens. We'd seen good examples in Europe. And part of the facade became, how do you actually have two screens, an operable panel, a place to stack the panels, and still create an interesting facade? So in working with Sloan, we kind of came up with an idea of these tracks with windows that shifted, blank opaque walls that shifted, and panels that could move on the outside. And at this point, I'll actually kick it to Sloan for this part.
That sounds great. Thanks, Brandon. So as you can see in the upper right corner, that's looking up at the south facade. So that's kind of an easy one to handle. We've got the sort of traditional fixed awning that casts a shadow over the glass during the summer months, but yet in the winter it allows the solar gains to come through. So that's easy. In the bottom right corner, as well as on the left side, in the bottom right corner, you can see that's the west facade. And you can see the panels that we ended up installing. And what they do is they slide in front of the windows, or you can move them away to the space on the side to store them when you don't want that shading or when you want to look out the window or whatever. And so it was very important to us. We needed to have some kind of exterior solution for shading the west solar gains in the summer. This is the primary facade of the building, and it's west facing, and there's tons of glass because of other constraints on the project. That was sort of where we had to put it. So it really made us need to come up with a great solution. We thought about other solutions. We thought about electric roller shades, and we determined that that was too complicated and too hard to maintain and operate over time, and that the controls were something that we probably couldn't figure out easily or without a lot of experts. So we decided to execute this system. And I have to say, initially, when Brandon and the architects start talking about things coming from Europe and there being these great systems, it makes me nervous because it's going to be very expensive. It's going to be in metric. We're not going to understand it and all that. And so what we realized is we didn't need their systems. We could just come up with our own. And so we ended up developing this system with Brandon and his team to use off-the-shelf hardware, stuff you can pick up at Home Depot, stuff that's been around for years, Husky hardware, rollers and tracks, very simple. We just left it unpainted, unfinished. It doesn't need any maintenance. We've had no issues with it. The only part that was custom were the frames. As you can see on the left, we've got an aluminum frame that's welded, and we've attached the cedar slats to that. So overall, it worked out amazingly well for not very much money, and it was a very good, simple solution to the building.
And then actually I threw this in since we did the run through, Sloan, but we were talking during the run through about whether people actually use them or close them. So this was Google Street View, late July last summer. And I was shocked to see literally most people by noon had kind of shut off the west glazing.
That's funny. I was wondering if that was a staged shot because you can't even see any windows, but that's what it looks like.
Yeah, no, and I go to Seattle for the summers, and I remember it was like it's been incredibly hot in Seattle year after year. So I took this as a sense that people actually understood how to use their unit. I mean, if you look at the top, 90% coverage, meaning they left their unit in the morning and they thought about what condition it would be if they left it fully open for the entire day.
Yeah, we've done a little bit of education for the tenants just so that they understand how the system works. Hey, it's summertime, it's getting hot next week. We just send them an email, say, close your shades, it works better, and it seems to be working.
Yeah. So the next thing we'll dive into is mechanical. And actually, I thought it's worth putting out there that one of the things that we've done on almost every passive house project in Seattle is put in for code alternates. And it's not that we're like perpetually violating the building code, but there's so many things in the code that are stacked against passive house, just built-in requirements because the code is developed by consensus. Normally, we don't do too many per project. You know, you pick your battles. But on this project, the alternate was actually for the eliminating exhaust and using the ERV for the kitchen exhaust, meaning the exhaust patterning, but then also to use the recirculation fan. And, you know, it's something that you kind of just have to do, but it was interesting. You know, we pick one per project. We try not to do a whole slew, and we try not to have it be something that the project's going to die on. But back to philosophy, we have been playing with unit by unit, neighborhood, or whole building mechanical. Anybody on this call has probably heard me say that I've actually often landed on, I'll call it neighborhood mechanical, just because I feel it's, at least at this day, the best current solution. Not saying there's not a better one out there. But I think, Sloan, if you want to kind of cover, I will say we did work with Galen Stengel. We've worked with him on probably a dozen projects, and you know, dragging him from Virginia to Seattle or Pittsburgh has become quite common.
Yeah, we, as Brandon was saying, I really pushed the team to evaluate everything. Like, can we do a whole building HRV? What are the pros and cons, costs? How does it work? Can we do unit by unit HRVs? Does that make sense for such small studio apartment units? Or should we do sort of more of a hybrid or neighborhood approach? And so we actually looked at all three, came up with schematic designs for all of them, and pros and cons and cost analysis, and we ended up with this neighborhood approach. You know, we don't want to go inside everybody's apartment unit to pull a filter and to maintain, you know, 36 different HRVs, and plus we couldn't find the right solutions, and the whole building had some pros and cons as well. So we ended up with this neighborhood approach where we've got some Zender CA350s in a closet off of the corridor. It'll serve the apartments that are right above and the ones to the side, and we can access that closet whenever we want to pull filters and swap them out. So it ended up being the best solution for us. And we had a little bit of vertical mechanical ductwork, which requires fire dampers in some limited circumstances. So we had that, but this ended up being the best solution for us.
Yeah, but I think in this case, it's a good execution of the vertical because it's only going one floor. So you're only hitting a set of fire dampers as you're moving through, but then you're hitting half the building with each. So you can see there's kind of like one on the north, one on the south, and then every other floor. So it became a really, really efficient way to kind of maximize those units. The other thing too is because these are small units, back to basic passive house, there's a supply zone, a transfer zone, and an exhaust zone. In some cases, our transfer zone is our kitchens. It's a little bit different than we've done in other projects, but really each unit is just balanced by one port that comes in and one port that exhausts.
Yeah, so talking to this slide here, you can see we also kind of realized, we talked about AC, like, well, you know, people are kind of starting to demand air conditioning in Seattle, the climate's changing and so forth, but air conditioning is just too expensive. There's no good air conditioning solution for 350 square foot apartments anyways. So we killed that, and then we realized, wait a second, we've got supply air coming into every unit. Maybe we can do like sort of a central heat pump, and we can deliver through the supplier. You can see on the diagram here, we can use the heat pump to go to a buffer tank, and we can deliver that. We can temper the supply air coming into the units. In the winter, we heat it. In the summer, we cool it. And there was, you know, concern about, well, tenants don't have control over this, and everyone wants to have individual control. Well, we already eliminated air conditioning. It wasn't going to be possible financially to do that on this project. So We're just saying we're tempering the air somewhat. We're not providing complete load for the cooling, but they're going to have a more comfortable unit than they otherwise would. So that's what this slide is about.
Well, I will definitely say, I think with the way that summers are going in the Northwest, the fact that we're having gigantic bonfires in the forest, you know, those in Seattle and Vancouver, it's been 3, 4, 5 years where there are just these periods where there's massive amounts of smoke and it's hot and it's smoky and you don't want to open your windows. So I really viewed this as kind of a way that actually does lead to a more kind of bearable existence in your unit with the way that summers have been going in the Northwest.
Yeah, I think one thing that I kind of realized before we jump into the solar is that in coming to all these decisions, one thing that really stood out to me is that it's not an all or nothing proposition. You know, it's not like we're either having air conditioning or not. And we really kind of sort of broke through some of the norms and standards that people think about, like, well, if you have air conditioning, it has to be individually controlled. Or if you're going to have an HRV, it has to exclusively serve your unit only. And what if a tenant doesn't have control? And there were a lot of those kind of questions that could have driven us to either just do everything and blow the budget or do nothing. And I think that as a team, we sort of came to realize that there were a lot of solutions that are hybrid like this that ended up making a lot more sense and being appropriate to this project. So that's kind of how we ended up there. And the same actually goes for the next slide, which is about solar. We had initially wanted to do PV on the roof, and we determined that if a 4-story building built to a passive house EUI, if you cover the whole roof in PV, you're going to be net zero on that project. The city of Seattle had some reasons why that was not going to be possible for us. And so we, by sizing the system down, we started to explore other options and thinking about our domestic hot water. I wonder if we could do that with solar. So we looked into a system, we had it designed. As Brandon was mentioning earlier about Seattle in January, there's not so much sun. So they designed the system for solar to pick up all the domestic hot water. Well, that was going to cover the entire roof with these solar thermal tubes. And we decided, well, that doesn't make sense. Then we can never add any PV later or anything. So we asked them, cut the system size in half, cut it by 2/3, and tell us what the production will be. And the cut it by 2/3 solution was still going to give us like 70% production because the system was being sized to a January week. And so that's why it was getting so huge. And so we ended up with a system that provides most of our solar hot water heating. We've got backup from a gas boiler they'll heat the tanks. And so that's how we ended up with a solar thermal system on this project.
Then finally, hate to say from the architecture side, details. I think we really were trying to make it kind of an exquisite place to live. I talked early on about just the need for, I'll just call it creative and interesting space within tight urban projects. I think from a development perspective, the same as Sloan, if your building amenity is like the limited amount of landscaping and circulation you have to figure out how to make it work and be enjoyable. So there's this tight courtyard in the middle. That's also our stormwater planter, but we have benches and some interesting seating around it. But then even one of the rails up above actually became a bench kind of up on the 2nd story. And we carried that kind of idea of the slats and the horizontals all the way kind of through the project, even to the point of like kind of framing in the exterior stairs. The interiors of the units, they have to work. It's tight. The kitchens are small. It is a 3/4 kitchen compared to what you might get at a normal apartment. You really have one window per unit, right? It's not like there's multiple rooms or other places you can go. So the level of finish, the way that it was laid out, the integration of kind of the HVAC in, even providing there's a ceramic electric heaters that will temper it beyond what the ERV will, barn doors to save space. And really kind of the court at night becomes just a beautiful place to actually be. And I think the way that a passive house project feels. I think there, as much as it's about the quality of the environment you're going to have, I think it's lost if we don't carry through within the quality of design. And so that is it. I think at this point we'll pass it back.